Hey guys, today we're going to have a refresher on what efficiency and energy is. So what it means to be efficient, for a device to be efficient, is that the energy gone into it goes to useful energy. So for a light bulb, an efficient light bulb, all the energy, well, most of the energy would go into producing light, not heat, which would be the wasted energy. So you have your input energy into your light bulb, and the useful energy would be the light, and the wasted energy would be the heat. Okay, so efficiency has essentially one equation, but that's separated into two. So we learn of the first equation of efficiency as useful energy output. So this is your output, your useful output, divided by the total energy input, which is this here. So your total energy going in, so your useful energy divided by your total energy. The second equation is your useful power output divided by your total power input. Now, these two things are exactly the same thing because we know that power is related to energy and time by this equation here. Power is equal to energy divided by time. If I want to rearrange that, multiply both sides by time. Power times time is equal to energy. So energy is equal to power times time. And I use this equation here, useful energy output divided by total energy input, and I sub for energy power times time in here, useful power times time output divided by total power times time input. And because the time for it to transfer is the same, we can just cancel the time, and then you're left with useful power output divided by total power input. Hopefully that makes sense. So what we've done is we've used the relationship between power, energy and time. We've rearranged for energy. Energy equals power times time by multiplying both sides by time. Then we sub this power times time into here for energy, and we have useful power times time. We cancel the t's because the time taken is the same, and then we're left with this equation here. So if you're given a question in the exam that says your total power input and your total power output and gives you values for that, don't be psyched, it's the same thing, so don't worry about that. Okay, now we're going to have a quick recap on energy equations. So over here we have kinetic energy, a half mv squared. We have elastic energy, a half ke squared. Remember, kinetic and elastic look very similar, but instead of m to the power of nothing, we have k to the power of nothing, and instead of v to the power squared, we have e to the power squared. Okay, then we have E is equal to mgh for gravitational potential energy, and E is equal to mc delta theta. Remember, this delta means a change in. Okay, so we're going to do two questions. So I want you guys to have a go, try it yourself. So the question is, you have a kettle, and by using this equation for thermal energy, we know that the specific heat is 4,200, and specific heat is the C in our equation. We know that the mass of the water, because we're dealing with the water here, is 2 kilograms. And we know that the change in temperature from when it's boiling is 20 degrees Celsius. So you have your kettle, you switch it on, you know the specific heat is 4,200, you know that the mass of the water is 2 kilograms, and you know that the change in temperature is 20 degrees Celsius. So try and work out the energy using this. Okay, cool. Hopefully now you guys have managed to do this. So my first move would be, I just sub these things in. So I have my mass, which is 2 kilograms. I have my specific heat, which is 4,200. I have my degrees Celsius, which is 20 degrees. Remember, I have my change in degrees Celsius. So if it just gave me initial temperature and final temperature, I do the final minus initial to calculate my change. So that is my answer for my energy. So 168 to the power 3 joules. So that's how we tackle the first one. And now we're gonna have a question on efficiency. So using one of these equations, I want you guys to try and work this out. So the total power input of your system is 750, and the total useful power output is 360. What is the efficiency? Give the unit. Okay, hopefully you guys have managed to do that now. So if we have the total power input, which would be our so if we have our total power input, which would be 750, and we have our total useful power, we do 360 divided by 750 using this equation over here, and we have 0.48. Now, I asked to give a unit because I wanted to trick you guys. There's no unit for efficiency, it is dimensionless, and what that means is essentially there's no unit, because joules divided by joules is just 1, which is no unit. Watt divided by watt is just 1. So the efficiency of our system here is 0.48. If you want to get that into a percentage, you